So this is yet another meeting of the ROS Lawn Tractor Automation Group. And let me stop sharing here. Bang. And what I've done, I haven't done much lately, but what I did was a couple of weeks ago, 2 or 3 weeks ago, I was on Amazon ordering some supplements like vitamins and stuff. And a little box popped up, says, "Oh, here's some other stuff you might be interested in." And again, they showed me the giant RC servo was like a buy. And I thought, hey, that looked like a good price. And it said something like, you can get this servo for, like I said, $50. I thought, well, that seems like that seems a lot better than $65. So I started clicking around looking for that. And I noticed that um, if I click on one that says $50, it was going to take like 3 or 4 weeks to show up. So apparently those were coming from China. This was all on Amazon. I was doing this, and I looked around some more, and then I found one that says, oh, it'll show up the end of the week, and it turns out that one was like $55. I think it's $55.80. So it's basically $5 or $6 more, but I didn't have to wait forever for it to show up. So I went and clicked on it and said, yeah, throw that in the trunk while you're loading stuff up, and it showed up within the week. And it surprised me because I ordered the one, it said the ASMC-04, which is what that was. Let me change my screen view, speaker view. So that was this one. It's this one happens to be the B version, and you get an A or a B. The A is 4 times faster and is 110 kilograms per centimeter. The B is 180 kilograms per centimeter, which is what everything else seems to be. Say down here it says 180 kilograms per centimeter, and they put a B sticker on. And I think what that means is the gearbox down here, you get one gearbox of the other, and I think the board on it is exactly the same, because if you look at the board there, I can pull up in a second. See down at the bottom there, it says ASMC-04 Wing Zing, and that, so it doesn't have an A or a B on there, so it looks like the board is the same whether you got the A or the B version of the servo. And again, I think it's just the gearbox. So that's just a guess on my part. So anyway, that's what the thing looks like. And in a second, I can pull up this thing on Slack here to show you the pictures. But it surprised me when it showed up. Is this going to work? So this is the one. This is the one that showed up in the mail, and it says it's an A. And down here it says 110 kilograms per centimeter, which is what I expected. And the thing right there, but it says ASMC-05A. And so the previous one I had was an 04, not an 05. So that kind of confused me. And then I was looking at the board. The board now says it says ASME-05. So instead of being an ASMC, it's now an ASME that's on the board. And I didn't realize that until yesterday. I was trying to upload photos. I spent a couple of days trying to find photos of the board on the internet so I could pull those up and show. Hold on a second. I got to play with my screens here. So how do I get back to? I can pull up something on Slack. Here it is. Let's go to make this bigger, and then let's say share screen. How do I share screen with this? Like this. So on Slack, I uploaded these images yesterday. This is the image of. So there's some trick that you got to say. Open this in new. This is really starting to annoy me. Put it over here. Okay. It says view for detailed. Open in new window, I think is what I want. Okay, let's say I'll check. Yep, that's what's going out. So there's a picture of the 04 board, and I think if I zoom in, no, that's the trick. You can't zoom into this stuff, can you? Try this. Go here. copy image, copy image. We say go here. Let's say open in browser. What's that do? Ah, there I can zoom. So if I need to zoom, I can. So let's go back here. So this is what the board looks like for the ASMC04. And that's what it says on the board right there. And again, you notice there's no A or B on that. It's just that's the board for the 04 version. And what I was noticing was this board looks like this. Now let's see if I can get the next one to come up. Back here, take this one, say open that one in browser. We'll see if this works or if it's going to wipe out my other one. Okay, I still got both here. So I dug through the internet, could not find a picture of the boards. What I did, I just held it up and took a picture with my camera. And this one you can see, I can zoom in on that. So let's go look at that. It's annoying that everything you pull up works differently. So anyway, this one says as ASME-05. And what I was noticing was, so the thing was what on the posting on Amazon, when I pulled it up, it said it was an 04, just like I was expecting. I ordered it. So it surprised me when I took it out of the box that it was something different. So it's got the new, see, I can't zoom in a little bit, can I? Anyway, the point was I've got this board and I've got this board. So this is what the old one was. And what I've noticed here is the old board right here. Yeah, I was gonna say, can you see my cursor? But I can see it in my newfound window that I just opened here. So over here in this area, there's a square thing with a like a thermal pad stuck to the top of it. I'm going to call that some kind of automotive driver chip. And I'm not sure what it actually is, but I think that's just something that they bought that from the automotive industry and they put it on this board. So this is what's driving your main motor. So it's got logic signals coming in from the outside world, and this drives it. And then this is the motor connector over here on the side. So that's the way the 04 worked. We go to the 05, which you can't really see here, but over here, so in this area right here, underneath the heatsink, there are 4 MOSFETs soldered down to the board. And then there are 2 MOSFET driver chips here, which control those. So that is replacing what it had on the older board, or I should say the other board. I'm not sure it's really older. And then again, it talks to the output connector over here. As far as I can tell, the boards are laid out the same. So the mounting holes are the same. So I think these boards are interchangeable no matter which one you have. You've got their gearbox and you put whatever board on you want. I think it will work. I think to the end user, you probably don't care. You just you put power on it, you put a signal into it. I think it will do what it's supposed to. So that was the first thing I noticed, is that this one has actual MOSFETs as opposed to that cute automotive driver chip. And I'm not sure what the difference between those would be. At one point I thought, well, maybe since they went back to MOSFETs, maybe they just simply can't get that other chip due to supply issues, or maybe they're having problems with it, or just simply cheaper to use separate MOSFETs and driver chips. But that's before I realized this is, and actually it's the, okay, we got to do this again. Since it's actually the ASME-05 is actually a different family of parts, and I'm not sure. Again, it seems to be interchangeable. It looks like it should work, but I noticed somewhere else, because if you go back, the ASMC-03, that one had the 4 MOSFETs and the 2 MOSFET drivers. Then they went to the 04, and that's where they came up with that automotive chip. And I thought, oh, when they went to the 5, they went back to the 4 MOSFETs. But if I look on Amazon and places, it looks like you can now get the 05 board that's got the automotive driver chip on it. So that one would be the ASMC-05. So it's real confusing. And since I got in just as the transition was happening, everybody said these are all 04s, but an 05 showed up. And now 2 or 3 weeks later, I go look at it, and you can actually buy stuff on Amazon and eBay that claim they are the -05 boards. So it all confused me, and it took me until last night when I was uploading these images. I didn't even realize the part number on this is a different part number than what the other boards were to start with. Although it looks like I could order one that would be the same part number, and it looks like it's get back to that automotive driver chip. So anyway, let's go back to what I was talking about here. So then also on that board, another thing I noticed was on the 04 board down here at the bottom, here's the microcontroller and a 16 megahertz crystal that's on the thing. And on the new board, or the other board, they moved the microcontroller chip up here. As far as I can tell, there's no crystal on it anymore. So apparently they're using the built-in oscillator of the microcontroller. So they don't need a crystal. So it may be a little more jittery because of the lack of a crystal. And I guess I don't know that until I actually try it. But I have it and I'll go ahead and use it. So that was the second thing I noticed. And the next thing I noticed was the original board, the 04 board. Down here, there's a 12-volt linear regulator, this big 3-pin part right there. That's a 12-volt regulator. And on the new board, or the other board, it looks like they replaced it with this 8-pin part here. That's like a switching regulator chip. And here's a capacitor and an inductor. Here, I can zoom in on that, right? So here's the driver chip, or here's the switching regulator chip. No, I can't move around. And here's a capacitor and an inductor and a diode that probably form a 12-volt regulator. There will be a switching regulator as opposed to linear, which means it's not going to waste as much power. It might have a better input range on what it responds to. And then I looked at it a little harder, and it looks like I'm thinking this is yet another switching regulator on here, and I don't know what that one's for, because it looks like this is probably the switching controller chip. There is an inductor, there's a diode, and there's a capacitor. So it's probably another power supply, and I don't know what that's for, unless it could be the MOSFET driver chips. I think maybe need a higher voltage. So it could be this generates a higher voltage than the 12 volts to make that run. And then over here, I think this is the same 5-volt regulator that was on the first board, because you need 5 volts to run all the microcontroller runs at 5 volts on this. So on the newer board, which may not necessarily be new, but it's I'll call it the newer board, the 05. So it's got that regulator there. And the other one, this is the 5-volt regulator down here. So I think they kept that. So that's the main differences I noticed between the two. Another thing I noticed was on the 04 board, it's got this giant resistor here. That's how they're measuring current on the motor. So this is on the low side of their H bridge driver. So between the driver and the ground going back to the battery, they got the resistor. And 05 might mean that it's 0.005 ohms. It's going to be some very low value. And then they feed that into the op amp to give them, so they can read, they can bump that up so the microcontroller can read that. And I don't know if it's wired as a comparator that simply says if you get to X number of amps, tell it to shut down. So it would be a digital signal between the op amp here and the microcontroller, i.e. they'd be using it as a comparator. Or if they're taking the voltage from the resistor and just amplifying it by, say, 100 or whatever amount with the op amp. And then this has an analog pin on the microcontroller. So it may know what the actual current is that you're reading at that point. And if that's the case, I could probably go in and solder a wire onto the output of this op amp and run it to an external board. And with an A to D converter, I could say, tell me what the current is, instantaneously tell me what the current is the thing is driving, or the thing is requiring. And instead of doing that on my SAMI 2, I got some of those little, they're like 3-terminal current sensor chips. I thought I had one laying right in front of me. I don't see one. You buy this little board on Amazon, and it's got the chip on it, and it's got 2 big leads, and you just put it in the series with where you're trying to read. So on SAMI 2, I just unplugged the power going to the servo and plugged this thing in between, and I can read that with a microcontroller to tell me the current that the servo is actually drawing, which other than just a debug or a curiosity, that's all I'm really using that for. It does get logged to my bag file, so I can go back and look to see how much current was it drawing at a certain point if I need to know that. And then I've also had a current sensor on the main motor in the back, so I can read the current on that, which I guess has nothing to do with the RC servo. I was talking about that. So anyway, the old board had this big resistor here, and then the other board, the newer board, has, let's see if I can find it here. So this is the op amp, that we were just talking about. And I think probably this resistor here is, so it's got a physically smaller resistor, and I can't read the part number on that right now. If I had my magnifying glass, I could probably tell you what that says, but I was trying to hold the thing up, with my hand, and then trying to take a picture with my camera. So I was trying to hold the camera. So it didn't focus as well as it could have. If I, well, it would have been smart, laid it on the table and then got my camera above and let it focus and took the picture, then we could probably read that part, but otherwise we can't read it. So the whole point of this is I the servo I ordered expecting to be the dash 04 version turned out to be a dash 05. And I just noticed that, they've done certain engineering things on here to either make it more efficient or whatever. And but I'm guessing in the long run, it's going to work just like the old one did. And this is, well, this is actually, let's see, how do I stop sharing? I don't think I need that. So this is the the 04B version. There's see on the back of the B, and it's the 04. So it means it's just got a different gearbox. So I've got one that looks just like this, but it has a sticker that says A instead of B, and it's the one that's 4 times faster and has less torque. But otherwise, the board on it, I get that to focus. Someday I'm going to figure out how to get the camera to focus. I see people watching people's YouTube videos. They put stuff up there that works just great. So I don't know what camera I need to make it do that. And then again, the new one simply looks like that, and it says 05, but it still says so this part number here. This part number here does not match. It says ASMC-05A, and then the one on the board says ASME-05. So that's why I'm thinking that the boards are all interchangeable and it should work no matter what. It's just a matter of what they designed in at the time when they were making the thing.
Can you show the shaft on the 05? Is it just a circular or is it a D?
The main output shaft,
Yeah.
they're all the same. They all look identical. It's just, I think if you tore it apart and look at it, it would have different gears inside, and that changes your ratio. So yeah, it's got the D shaft, has the 8 millimeter, and the standard things that they sell you to go on there fit really well on any of them. So I guess I haven't tried it on this one, but I assume it'll fit. While I'm sitting right here, I was thinking, I'll take this off. Let me take a screwdriver. So here is one of those adapters that you buy to go on the thing, and they're made out of steel and they machined them really well. And I just took it off of this one, which is the one I was using before. So we'll see if it fits on the new one. I'm guessing it'll fit because I'm sure it's the same identical gearbox on this one as it on the one upstairs. And yeah, it fits on just perfectly. It fits on there, and there's a little bit of, you can see a little bit of slop. And I haven't tightened up the set screw, but that's just how tight it fits on that shaft. Let me try it on the other shaft. And depending who manufactured these and when they were done. No, it fits the same way on this one. So that's maybe even a little tighter on the newer one, but that's just how much slop it's got until they tighten up the set screw. But you put torque on it, and that the D shape is handle a lot of torque there, so that should work out. So I think that's all I have to say about those. I just simply ordered it because it popped up, and I decided I want to replace the one on Sammy too. So I've got the faster steering, so I could test out that theory that you need fast steering to make the algorithms work that we had. I still think you shouldn't have to do that, but I haven't sat down with a simulator and played with that. I should do that one of these days and see if I can figure out how to fix that and make that work without having to put the faster servo on. And the point was, I simply wanted to. It was just easier to buy a new one and leave the fast one on my little robot that I made, which I haven't got around to finishing, and then I'll just have the new one here. So I could, if I really want to go the trouble, I could take that one off the small robot and take the new one and put them side by side and verify they both work the same, even though one's an 04 and one's an 05. I think they should work exactly the same, but I can't tell until I actually try that. And again, these have the down here on this red jumper. If you pull that jumper block off, that gives you a position feedback. So it takes the potentiometer here, runs it through this op amp here, and it runs it through a 10K resistor to this connector here. So if you pull that jumper off and hook an A to D up to that, you can actually read the position of the thing. And the one I had, the one that's on Sammy 2 right now, is the same one that Al just bought recently. It's that DH03X. And that one, I pulled the board off because the pot was on the back of the board. So I pulled the board off, soldered a wire on, just ran it out and hooked that up to an A to D converter. So that one I can read the position on that one. Because on that one, they didn't think ahead to give you that. It could be it's on there. Because they don't label this stuff, so maybe it's really on there. I don't know. But I was able to get it to work. I did put a big value resistor in series with it. So if my little Arduino that's measuring the position shuts down, because that's just plugged with a USB cable into the laptop. So if I unplug that, the microcontroller loses power and its voltage drops to 0, and the production diodes pull your analog line down to 0 volts. And if I didn't have anything in between that and my RC servo, the servo would say, "Oh, it's the wrong position." It would go wham, and it'd slam up against the side. And I didn't want that to happen, so I put like a 100K resistor or something in series with it, because I knew ahead of time I was going to do that. So I put this resistor on, and still, if I have the little Arduino Nano plugged in or not plugged in, when it's plugged in, it's like this. When I unplug it, it goes zip, it moves over, turns it like about 5 degrees, because this thing's loading the thing down through that inline 100K resistor. So that was something else. Now on these, there's still yet another problem on these, because since it's got a 10K resistor in series right about here somewhere on the board, talking to those pins, that means if you start putting voltage dividers on that, it's going to load it down and give you the same problem. So I've got a theory I can put an op amp in between that and whatever I'm trying to talk to. And one of these days I'll try that experiment, and I can document that and say, this is how you do that. And that should work for either this board or that original DH03 board. Because if I just buffer it, then no matter what I do on the output of that op amp, it's not going to affect the RC servo itself. So that was just some more comments I had on that. I could still go through the experiment where I set up the servo like on this one. The one day I was showing 3 of these running at the same time. But then if I do that and then take the output from here, I could just run an experiment that says I want it to go to this many degrees, whatever PWM that is. And as long as I calibrate that position voltage coming back out, then I can say, I tell it to go here. Does it go exactly there? Does it go too far, not far enough? And I can compare all the servos to see how well they're actually tracking. And it would be interesting to do that with no load on it, like it is right here. It just had an arm on it, or hang a weight out here on the arm, or put a spring on it, or because in Al's case, he's pushing against another lever arm on his transmission. And transmission has a big spring in it that's trying to do a spring return to 0. So under different circumstances, it would be handy to know what these things are going to do, how they're going to react when you try to do that. So that's just the fact is all spurred by the fact that Amazon says, "Hey, you might want to buy one of these too," while you got the trunk open. And I did, and that took me down this path. So it's got me thinking about stuff, and I don't really need to think about anything else right now, but that's the way that goes. So I'm going to say that's all I have to say for today.
Okay. Well, following on then with servos and control, I have this cable that I bought. And as Jeff mentioned, my transmission on the Cub Cadet has a big spring in the transmission, the hydrostatic transmission that returns to neutral. And best I can tell, it's about 40 pounds of pressure. And at the moment, I have a servo different but similar to what Jeff was talking about in the wear in controlling the servo in the past has presented a problem. So I was thinking about different physical options on controlling that transmission, and maybe moving to a motor that's driving a linear motion device, and one end, say this end, is hooked to the transmission and controlling the arm, and the other is mounted in such a way that the motor is just pulling this back and forth. This gives you about 2 inches of play. I think on the hydrostatic transmission, it was 1.5 inches forward. It'll be close. Because let's just say the forward was up to 1.5 inches and reverse was 3/4 of an inch. I mean, that's the kind of play that I'm looking for. So this came out of this was on Amazon as well, but it's for an automatic transmission. And there's a place to mount here, and it would definitely handle the 40 pounds of torque. The other option, although I'm not a transmission guy, the other option would be, what would the transmission still work if I took out that return to zero spring? But that's got some safety implications to it. And so at the moment, I'm still going down the path of trying to control that. So the only thing I've done is thought about it and bought a cable and to help me sort of think through the design implications of switching to this sort of control on the transmission instead of the direct servo connection. And there's about from that red orangish part to this red orangish part is about 3 feet. So with the connectors and whatnot, it's about a 4-foot end-to-end deal. So
While you're holding that up, the end that would be the non-transmission end, it's got some threads and a nut on there. Do you know what kind of thread that is? I assume it's probably American threads, and it's probably either 1/4 inch or 3/8 inch.
I haven't measured it yet, but it's smaller than a 1/4 inch. So I don't think I have my calipers handy.
Because the thing you want to
not as
know,
big as it.
because if you want to put one of those ball joints on there, you just make sure you get the right hole size and the right type of threads, and then you can screw a ball joint on there, then hook onto your servo or whatever you're talking to. So, but just make sure you get all measure the threads per inch and the diameter, so you know what the type of thing is. So you just order the right part to go on there. If you got some laying around, you could try them and see. And yet, number one, you have to say, is it metric or is it American? So you have to figure that out. And if you happen to have, some nuts laying around that what sizes they are, you can try them on there and see what
Yeah,
to screw on there.
it's about half the size of a 1/4 inch. So, and
Well, that's really small. Are you sure that?
well, I have another thing here that's a 1/4 inch, and yeah, it's only taken up about half of the
Huh,
half
it
of
just
that.
looks bigger when you hold it up and in front there, I guess.
That's yeah. Anyway,
And also, before you order anything, make sure that that's got the right, right hand threads as opposed to left hand threads. Which if you're ordering ball joints, you can get them either way. So yeah, again, you just make sure all those pieces go together before you, so you don't have to order your part 5 or 6 times to fit on that.
yeah, I didn't see a lot of options on this that weren't like crazy expensive. So I said, I'll just go ahead and get that just to see what it's like and what it might take to hook it up, because it definitely would have to have some sort of mounting thing there, and definitely have to have, a joint to get from this to the whatever is going to pull it back and forth. Um, so anyway, that's
Also,
one
that
thing.
will allow you to mount the cable where your servo currently is, and then run that cable up. So you're not going to be jammed you're not trying to jam a servo down into the available space. You can mount the servo anywhere you want. And once you get the servo out to where you can get to it, you might want to consider, as you go and put some micro switches on it at both ends, for in travel limits, if it's convenient. or you could even put, something to just measure the angle if you wanted to. So you get, once you get it out from underneath where you had very little room to do anything, you can now say mount your actuator to a board and put it up where you can get to it. So you got a lot more options of what you can do there, trying to control the thing or trying to maybe sense it and control it or whatever.
Yeah, those are all good points. And I was, I don't think I could turn it into a pretzel without having a really heavy motor on one end. But yeah, I'm hoping to have a few more design options by using that. So, um,
And back to your statement, you said you didn't know if it'd work. If you take the spring out of your transmission, will it still work? I think it'll work just fine. I think that's the way mine works. I don't think mine has a spring. It because mine didn't have any spring return to zero. Mine just got a lever on the side, and if you push it forward, you go forward. You pull it back. It just got a little plastic notch that stops it at zero. And in fact, mine even has down at the bottom, it's got a little friction brake. So it's got a friction brake and a spring so you can tighten it up. So because otherwise you push the thing forward and you're driving down the road or driving down the yard, you get halfway across the yard, the thing slowly starts creeping back like this, and it'll finally come to a stop. But you can go and you can crank that brake. So you push it up here to go full speed forward, then it'll stay there. It just takes more effort to move it than if you got that brake on there. But I think your
hmm,
transmission would probably work fine with the spring. But yes, then you have to question, do you really want that? So it will snap back to zero. Say if your cable breaks or whatever, that might be a handy thing to have. And the biggest problem
yeah,
is to take that out, I think you have to tear your entire transmission apart and pull those pieces out to remove that spring and then put it all back together. And you have to decide, do you want to attack that if you don't have to?
yeah. At the moment, I'm gonna safety first, leave that in there, and see if I can think through what it might look like using this cable to something that'll deliver 40 pounds of torque consistently. Oh, I mean, the other one would deliver it consistently. I was just dealing with um, wear and tear on that shaft from where the set pins, were moving ever so slightly and drilling that in, so, or causing damage. So anyway, my speed control is pretty limited at the moment because of that, because I'm trying to baby it before it breaks. And by baby it, I mean I just set it to one position. I don't try to manage the speed. I just try to sort of guess what my speed is going to be and deliver that setting. So anyway,
Another quick
um,
thing you could do on that, since the spring is always it's always fighting you with about 40 pounds of force. Just at your servo, you can put another spring that's pulling against that. Now, that's only going to work in one direction or the other. So if you just want to go set it up for forward, put a spring that's already pulling 20 pounds of force in the forward direction, and then your servo only has to work against that amount. But now you go to reverse. Now you can have the two springs added together if you're trying to go backwards. So if you think you're going to go forwards most of the time, you can just put a spring to counteract the spring that's in there. It's just that uh, when you go to back up, it's going to take a lot more force to move it then to do that. And you have to decide, can you get by without backing up? But that's another thing to consider. Or for right now, the fact that you are putting so much force on that servo and tearing up the shaft on it. If you put the spring directly from the arm on the transmission, pulling pulling it in the forward direction and give it like 20 pounds of force, you could put it like a full 40 pounds of force on it. And now the servo basically sees very little force moving it back and forth. It's just that if you try to go backwards, now you have the two springs are adding to each other, and that would be a problem. So that's just something to maybe consider.
yeah, at the moment, I hadn't thought of that. At the moment, I only operate in the forward position, and I've only used reverse when I put it away. Um, but that is something to think about.
Now, when
The
you
other
go to
thing,
when you go to put it away, you could just, I assume yours has, like mine, it's got a lever on the back. You pull the lever and it disengages the transmission. So you can just push it by hand and then, back it into your garage at that point. So if you don't have big
Yeah,
hills to go up.
all those design options. Um, the other thing that spent time on, let's see, I mentioned in the Slack channel. I had never really tried to use an ESP32 to use integrated with Google Sheets as sort of a data logger. And I had the occasion to be curious about temperatures of some things. And so I used an ESP32 with a few different temperature sensors or other sensors, and wrote a little routine to pull those and post it to a Google Sheet. I mean, and so what that looks like is, um, let's see, how do I get back to my Google Sheet? Oh my, this goes into full screen and I don't like it when it does that. How do I get out of full screen? Dun, 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 dun. Dang nabbit. Well, while I'm here, I'll just tell you what I did with these. Um, I ordered some stuff like Jeff had. Well, I can't even get that up now. Let's make that screen smaller. And then we'll go back and share. Bear with me just a second. Okay, share.
Now that you're sharing, Dave, do you have a tab at the top that says view options? Mine right now says you are viewing Al Jones screen in green, and the next one says view options. If, if you have that tab, pull that down. That I think has things like full screen and other stuff. So you might have to move
Yeah,
your cursor clear to the top of the
sharing.
screen to get it to show up.
Yeah, it says you're sharing, but I don't see view options. Do you?
Yeah. Yeah, I think they want to make this as hard as possible, is what they're trying to do. As an option, they want to make it as hard as possible.
Anyway, I found these. Jeff had mentioned earlier that he had found some adapters to get from his um, GPS antenna to a smaller size, and I found these, so I just wanted to mention that these had a number of pieces, and so you get the male side that will screw into the GPS antenna, and then it gives you the different size. And these come in two different sizes, quarter inch and 3/8.
So just a
So
note on that, you have to make sure the threads are the right kind, because these are not the right, the 5/8 is not the right number of threads. I think you need 5/8 11, and these are like 5/8 uh 20 or something. I'd
oh,
say,
well,
see, they don't mention that anywhere. If you scroll down where it says description, it might say 5/8 and then give you the thread pitch. And if you dig around, you can buy them multiple ways. So you have to make sure when you go to buy it that you have to look up what is the one that goes in the GPS antenna. I think that's 5/8 11. So it's 5/8 inch diameter, 11 threads per inch, and then probably go down the place where it says descriptions. You have to scroll down a ways. And yeah, like down in this area somewhere. Product description, it might tell you there. And they're probably saying, well, it works with microphones, so they assume the microphone has a certain threads on it.
Mm.
And it doesn't look they're going to tell you that here. So you just, in this case, you just have to look at it and say, is that the right size or not? But see, these will not work with the GPS antenna because it's got the wrong kind of threads.
Okay, forget I said anything about that. Back to the using an ESP32 as a data logger. Come on, get off of that. I mean, the process is not terribly complicated. You set up a Google Sheet. You have to put, I'll call it a macro or a script in the Google Sheets that tells it what to do when it receives data that's been posted. It's taking a little bit of time to load. This is what that code looks like. I posted it in that Slack notice, and basically, you say, hey, these are the parameters that I'm getting, and you get an ID for the sheet, and then when the data comes in, it appends the row. So that's pretty cool. And this URL gives you a big long code that you then go back and use in the actual code. And so this is the ESP32 data that's not very complicated. There's just a loop here to gather the data, and then I've got a function about sending it to Google Sheets, and that function is basically creating a long URL, and I'm going to say it posts a get statement, and then you get a code back on whether it was successful or not. I was getting a 302 error a number of times. Still not quite sure why, but the data was being posted, so that was cool. I also I connected up my ESP32 to a battery, and still some peculiarities I need to work out with that, but I was trying to put it into deep sleep to extend the life of the battery, so that was something else that was going on. So I was thinking, linking it to robotics. If I'm out in the field and I do have a Wi-Fi signal, I could post the GPS location, and that would be putting it into a non-ROS public area, and I might be able to do some interesting things with knowing exactly where it was at different times. And it depends on the Wi-Fi signal, but I was just posting like every 5 seconds when I was testing, and it seemed to handle that fine. You're not going to get, it's a website, so you're not really going to get high latency or low latency response, but it was interesting and useful, I think, for figuring out how to get data off of a sensor and into a public place like a Google Sheets in order to do something with. So I thought I would share that. And that's about all I had for today. I've got to continue to work on my.
Do you have direct links to these two pieces of code that you could put in chat? And yes, you did post it to Slack, but if somebody's watching the video, they probably can't get to Slack. And then also everything on Slack disappears after 90 days. So it'd be handy if we could just post a link. If that's convenient, we could do that.
Yeah, I can do that. I don't, to answer your question, no, this is sitting on another machine at the moment. I can move it into my GitHub and put it out.
Well, we
Put
could
it out.
always add it in later too. It's just that, just you have to keep in mind that stuff we put on Slack isn't, number one, it's not going to be there forever, and number two, people may not have access to it. So, they're sitting and watching and just scroll by and think, yeah, that's real cute, but they can't get the full gist of it by just watching it on this video.
Yeah, I have to move it into a place where I can post it beyond Slack. So that's what I had for today. I got to get back to well, now there's not snow on the ground. I can go hopefully finalize the position for my antenna on the where I was testing and put that in a fixed location, get the fixed data about the lat long of that exact location and put that in the configuration for the GPS. So that's my next real step besides messing around with cables and temperature sensors.
What was your outcome? You said one of your GPS receivers didn't work anymore. Did you get any further on that?
No, I have it laying on the table to look at, but between Texas and some Texas weather and some other things, I haven't spent any time on that yet.
I didn't even remember what the issues were with the last meeting we posted. You were saying that your base station wouldn't talk to you, and we had several thoughts on it. I just wondered if it was something easy. So, oh, I got to turn the switch on or plug the cable in or something. But I guess you haven't got that figured out yet.
Not yet. And it was base, thank goodness it's base station 2. It was for um, the robot in Texas, not the one in Pittsburgh. So I still have a working configuration in Pittsburgh.
So don't break it.
Yeah, exactly right. I think you can turn off recording for this week.
Stop recording.